we're going to continue. You may have already finished this lesson on your own because the full video was up in its learning. But just in case, I'm going to cover it and you guys can get the work done. Slope fields. When we talk about slope fields, it's a picture representation of a family of differential equations. So you in the last lesson we solved a differential equation for a general solution. Well, a slope field is exactly a picture of all possible solutions. It depends on how much you want to zoom in on it. And then within that picture, you could isolate it and find one particular solution that we were interested in. So that's towards the end. So their definition, a slope field is a pictorial representation of all possible solutions. You remember when we had the y equals f of x plus c. Well, that c can be so many different things. F prime of x, or dy dx, that was the equation we solved for. The solution to a differential equation is a function, f of x or y. There is an infinite number of solutions to a differential equation. Show all your work. Okay, let's do. When he says show all the solutions, he's asking for general form. Okay, or the general solution. I'm sorry. So this is just a review. I'm going to separate the variables and make dy equals to x plus 3. And I separated the dx. All the y's are on one side. All the x's are on one side. The dx is with the x's. The dy is with, well, there is no y's. But there are no x's on the left. So therefore, you can consider it a constant of 1. And so it doesn't have any x's. So you're good to go. We integrate both sides and we get the y is the integral of 1 with respect to y, and that gives me a quadratic x squared over 2 plus 3x plus the constant. Well, there is your equation that is the general solution for every differential equation. Let's see. My brain is rusty. For the AP exam, you are expected to be able to do the following 4 things with slope fields. Okay, you should be able to graph a slope field given a specific equation for dy dx. You should be able to sketch a particular equation from, or I should say within, let me put within a slope field. You should be able to match a slope field given match a slope field, let's see it match a slope field to a given differential equation. That means you have a dy dx And you're going to find the slope field that matches that. You should be able to match a solution of I'll call it a diffie Q. Match a differential equation, so you match a solution of differential equation to a slope field. This means particular. This means, let me put it in red. This means you're going to match the particular solution. This one is you're matching, number 3, you're matching the general solution. Page. No, that was an x plus 3. Oh, close. All right, here's how we start graphing a differential equation. When you see dy dx equals x minus 1, this means the slope is always related to x minus 1. Each of these ordered pairs that you could identify have a coordinate of x comma y. So it's just a matter of basically plugging in. I'm just going to do some of these points here. I'll do a couple more here. Okay. The AP test may not have you do a full set like this. You could just do maybe, it's amazing, they could just have you do just those 9 and call it a day. Or they give you these, just that set, and they call it a day. But you could go on forever, technically. So let's start with this far left row. And we'll start with this ordered pair right here, -3, that's a -2, 0. So you need a lot of room here because I'm going to start with just point -2, 0. And the only thing I have to plug into this equation is this x. So that turns into the slope at that point is -2 minus 1. That's a -3. So how do I show a -3 slope there? Well, remember what slope means, rise over run. And it's negative, so it has to go rising to the left. So if I go up 3, 1, 2, 3, and then over this imaginary 1 right here, that line segment would have a slope of -3, which is what I want. But I'm not going to draw that whole line segment. I'm just going to draw a segment where that point's in the middle of it. Well, you can do better than that, maybe. Aiming for that point. It's pretty steep. That piece of segment has a -3 slope. Let's go ahead and do another point. Let's do this point right here. That is a -3, 1. So at not 3, -2, 1. Again, I only have the x to plug into, and it's still just a -2. So that slope will be -2 minus 1. Again, that's a -3. You mean it's parallel to the first one I just did? Sure is. And then I'll do -2, -1. Let's do this one. -2, -1. Again, only has a -2 to plug in. So that gives me the slope of a -3. I hope you figured out that this whole column has the same slope. So I just try being accurate and make them all look like a steep -2. Let's jump over to the next column, the next x value. This is a -1. This is when x is a -1. And if you think about it, I'm only plugging in the -1 every single time into this equation. So if I just pick the 1 point here, if I pick the point -1, 0, and I plug in the -1, I'm only getting the slope of a -1 minus 1. That's a -2. So it should not be as steep as that first one. So I go up to over left. I'm going to aim for that point. So it shouldn't be as steep as the red one, and all of these should be parallel. The AP grader will be looking to see that the one here is steeper than this one. They're not going to take a ruler there and measure the perfect slope. This is just a sketch. Let's do the y-axis here. The y-axis is every x value is 0, but every y value changes. But since there's no y in the equation, it's going to be 0 minus 1, which is a -1 slope. Wait, what did I just do? Did I do a -1 slope? Oh, that was supposed to be a -2 slope. I'm just going to make sure those are all well, they are all -2, I think. Didn't I point? I pointed 1, 2 over 1. I have to aim for up there. Yeah, I think I did. So -1 is the y-axis, which means I can take any point, just do this, go 1, 1. So it's going to be less steep than the last one was. Make that whole column parallel. And keep on going. Let's do the x equals to 1. Now when x equals to 1, your slope will be 1 minus 1. What does that turn into? That's a 0. So everywhere that x is a 1, the y's are constantly changing, but that's not part of the equation. So I'm always going to be plugging in a 1, and that's going to be a slope of 0. So that looks like this. Slope of 0, 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 slope of 0. And we have one more column. Let's finish it up. That's when x is a 2. And since your slope is always going to be x minus 1, for that whole column right here, when x equals to 2, that slope on that whole column will be 2 minus a positive 1. So I'm going to start, I'll start do this one right here. Up 1 to the right 1 is how it's aiming. It's aiming. So every one of these are parallel. And now what we have is a picture of very many solutions. And you're not required at this point, I don't think. Let's see what he says. Well, he just said make a small tick mark for the slopes. That's what I did. I'm going to share with you why there's a lot of general solutions in there. If you follow the roadmap and you stay between the markings, you see that if I stay down here, I have that picture. Well, actually, that 0 slope should mean something. Let me try to take the next one. Let me move that one up. Let me go a little higher so I can give you what a solution here. Here it goes. Stay on the roadmap, stay on the roadmap, and then this is flat. And then there you go. Stay on the roadmap, stay on the road, flat. See? And there's a lot of them. Each of these is a particular solution. There's even solutions in between those. Stay on the map, stay on the map, stay on the map. There you go. Flat right here. There, see? And we didn't solve it. We didn't solve the differential equation. You know, we didn't take dy equals x minus 1 dx. We could have. That's what it was. We could, well, did we solve that one already? What was it? I think we did it. Well, what does that look like to you, though? What has one slope of a 0 and then the rest keeps getting steeper and steeper to the right? What kind of equation that looks like? It should look like a parabola. I'll prove it to you. Integrate y equals x squared over 2 minus x plus the constant. It is. It's that equation. Each of those are that equation. Your vertex seems to be on right here on that line. All right, let's do another one. Now this one's more fun because it has x's and y's. I'll start with x's and -2 again. So when the ordered parallel pick would be -2, 0. My slope there would be a -2 minus the 0. That's a -2. So I'm going to aim down 2, right 1. I'm going to aim for that point right here. If I go to the next point, let me do this one right here. -2, -1, -2, -1. I'm not lucky this time because the y's are changing. So if the y's are changing, I don't have a whole column full of the same thing. That slope will be -2 -1. That's a -3. So it got steeper here. 1, 2, 3 to the right. It's going to be much steeper. Much steeper. How about the point -2, -2? At -2, -2, that slope is -2. Did I do this one right? -2. That should have been a +1. -2 minus -1. That's what I get for not having you with me. -2 minus -1 is a -3. This one should be even steeper than I said. 1, 2, 3, 1. Maybe I did do it. I don't remember. But it's very steep. And the one underneath it here, -2, -2, gives me a -2 minus a -2. -2 minus a -2. That turns into 0. This one is a 0 slope. Let's keep going up now. Let's do the -2, 1. -2, 1. That slope will be -2 minus 1. That's a -3. -2 minus a +1 is a -3. So this one is -3. I'm going to go aim 3 up. 1, 2, 3 up, 1 to the left. So it's very steep. It's the same as this one right here. Let's do -2, 2. So -2, 2. That slope will be -2 minus 2. That one's going to be a 0. So that's a 0. -2. No, should that be right? -4. Not 0. -4. Even steeper than the one below it. It's kind of hard to do it steeper. So you're going to have to use your imagination. 1, 2, 3, 4. 1 to the right. Well, left, I mean, because it's negative, right? Where was I at? -2, 2. 1, 2, 3, 4. It's going to be very steep. Very steep. Oh, not right. Should be steeper than the one underneath it. Last one in that column. -2, 3. -2, 3. That gives me, using x minus 1 again. Still this. No, I'm sorry. I think I reverted to the last equation. Where's my work? -2, 1. Yes, I did it. -2 minus the 1 was a -3. This is a -2 minus the y. It's a 3. It's a -5. That slope's very steep. 1, 2, 3, 4, 5 over 1. It's going to be left 1. Even steeper than the one underneath it. It's almost a vertical line. Next column, when x is a -1. But y's are changing, so it's not as easy as that. Remember what my differential equation is. Y prime is x minus the y. Double check it. X minus the y. So if I'm doing, start the bottom. Let's start -1, -2. That gives me a -1 minus -2. -1 plus 2. That gives me a positive slope of a 1. 1 up, 1 to the right. Looks like that. Let's do -1 negative 1. That gives me the slope will be a negative 1 minus minus 1. That gives me the 0. I think I do see a slight pattern. Let's do negative 1, 0. Negative 1, 0. That slope will be a negative 1 minus 0. That's a negative 1. It flips. There was a positive 1 here. Now it's a negative 1 here. That's weird. Let's do negative 1, 1. Negative 1, 1. The slope will be negative 1 minus the 1. That's a negative 2. 1, 2 left. I'm going to aim up that point up there. Steep in the 1. Now I'm at negative 1, 2. Negative 1, 2. That slope is negative 1 minus 2. That's a negative 3. So 1, 2, 3 over 1. So it's going to be, it was positive, right? Look at it again. It was negative 1 comma 2. Negative 1, yeah, negative 3. Whatever was going to get positive. Negative 3. 1, 2, right here. 1, 2, 3, 1. It's going to be steeper than the last one was. Got one more there. Maybe you can't see it because I wrote on it. We got another point. Right here. Negative 1 comma 3. Negative 1 comma 3. Negative 1 comma 3. And the differential equation was x minus y. Slope would be negative 1 minus 3. That's a negative 4. Very steep. Very steep. Very steep. So I'm just going to make it steeper than the last one. Now I'm on the y-axis. Start at the bottom at negative 2. 0, negative 2. So you can easily run out of room, that's for sure. Remember, y prime is x minus y. Always remind yourself. So I'm at the ordered pair of 0, negative 2. So 0 minus, slope is 0 minus minus 2. That's the slope of 2. So this point is 1, 2 up, 1 to the right. There it is. Let's do 0, negative 1. That slope will be 0 minus minus 1. That slope is a 1. 1 up, 1 right. Not as steep as the one underneath it. Let's do 0, 0. 0, 0 gives me 0 minus 0, 0. So this one is a 0 slope. 0, comma 1. I'm looking at right here. 0, comma 1. Slope is x is 0 minus 1. That's a negative 1. So looks like that. 1 up, 1 left. 0, 2. Slope will be 0 minus 2. That's a negative 2. So I need to know that next one has to be steeper than this one. 1, 2 over 1. So it is steeper. 0, 3. Let me go up here now. 0, 3. And my slope is x minus y. So it's 0 minus 3, negative 3. Did I think that was going to happen? So it's steeper. It's negative 3. All right, let's continue. Wow, there's a lot of points. AP test never makes you do all these points. So let's see what's happening here. Let's see. Let's see what happens at 1, 0. So you need a lot of room. I could just do all those. You know, I know my y prime is x minus y, and I'm at the x is 1. So I could say 1 comma 0, 1 comma 1, 1 comma 2, 1 comma 3. Get all those points right there. 1 comma negative 1, 1 comma negative 2. How far did it go down? It only went to the negative 2. So that's all of them. Let's just do it. It'll be faster. Slope will be, it was not x minus 1, it's x minus y, right? How soon us old people forget x minus y. basically this one minus this one. So that one's a 0. 1 minus 1. Oh, I didn't do that. It was a 0. Do the 0. 0 minus 1 will give me a negative 1. When did I get the 0, 1? It wasn't 1. It was 1, 0, and 1, 1. So 1 minus 1 is 0. 1 minus 0 is a 1. So it's a positive 1. This one is 1 minus 2 is a negative 1. 1 minus 3, that's a negative 2. 1 minus minus 1 is a positive 2. 1 minus minus 2 is a positive 3. So let me start. 0 was a 1. And then it was became a 0, negative 1, negative 2, negative 3, negative. It switched signs, right? 1 minus 3 is a negative 2. So let me do the ones that are going up. It was a 1, negative 1, and a negative 2. A 1, a negative 1, and a negative 2. That was the 0. This one was the 0. It was a 1. And the 1 was a 0. And the 2 was a negative 1. And the 3 is a negative 2. Negative 2 is even steeper. You should see that it looks like the diagonals are the same slope. Let's do the two negative y values. Negative 1 was a 2, and a negative 2 was a 3. So it flipped. A negative 1 was a 2. 1, 2, and that's going to be that steep. This one's 1, 2, 3 over 1. That one's going to be steeper. All right, I'll let you finish up this last column. I can see a pattern, though. I can see that I have a road in here. And it looks like it's leveling out here. Well, this is just a weird one. I'm following this row right here. It's probably going to get steeper there. Probably the same as this row column here, but just steeper. All right, let you finish that up. And I'm going to go to the next problem. That's it for that page. Okay, remember one of the things, you had to graph a slope field. Now here's a slope field already graphed. And he wants us to, we have the differential equation that was used to create it. That's the same one we just did, x minus 1. It looks like we may have done it back there. Sketch the solution curve through this point, 1, negative 1. So you got to find 1, negative 1. That's this one. So if I'm sketching this one, I just have to treat like every tick mark that's left and right of it is this, it's the path. So I really want to go up to here, and I don't have nothing else past that. Then this road obviously is going up this way, then it gets steeper up this way. So the curve I'm going to graph will be following the road less traveled. That would be my solution curve. You probably can draw it better than me. Basically, you just keep it in between fields that are already done for you. Okay. Sometimes we get steered off, and you know, I forgive you because no one's perfect. That's the one we want. To do this, you find the point and follow the slopes as you connect the lines. That's what I just did. That's the second thing you had to do. Take a slope field and identify a particular solution. Next problem. Is there another one here? No. Okay, the next thing required to know on the AP exam is matching. Let's see what he's talking about here. Since the slope field represents all the particular solutions of a differential equation, and the equation represents the antiderivative of a differential equation, remember that when you have, you're integrating dy, and there's a dx here, you end up getting y equals the antiderivative plus c when you solve it. It says here that the slope field should take the shape of the derivative of the of dy dx. And match the slope fields to the differential equations on the next page. All right, this is going to be a little harder because I might try to make a copy of that page and bring it over here. Let's see what it looks like. Let's copy this. If I can remember how to copy. Well, that wasn't that good enough. Oh, it's copying everything. Well, that's fine, I guess. Yeah, let me do this. And I go to this page and I try to paste it, but I don't want that on top of. Well, let me move it. Okay, I can move it. All right. So let's start with this first one here. Think about when I separate the variables. I know that y is going to be the derivative of the derivative of what is sine of x, and that's derivative negative cosine plus c. So I need to find where I have a bunch of upside down cosine graphs, which looks like this. Cosine starts up here. That's cosine. And obviously it continues over here, right? But I got to flip that because there's a negative in front. So I need the picture that's going to be in red here. I need that picture. And let's look at all of them to see if any of them could possibly be it. Does that look like have similar shape? A doesn't. B doesn't. C's interesting. I'll draw a particular solution. Let me draw up here. It goes up that way, levels out here, and possibly out here like that. That, no, it doesn't look like a cosine. These look like parabolas. These look like something undefined at x is 0 because look, it's getting very vertical. This looks like a pattern I could almost deal with. Let's see. Let me draw one here. And I'm just guessing, just like you would have to. That looks more like a sine curve. Let's find another one that has it. Okay, here's something that looks good. Could this possibly be? See, it goes up, comes down. Could that possibly be it? Or could this possibly be it? That also looks like it has a... Kind of tough, isn't it? So, I told you these are hard. My best guess would have to either be, well, D is definitely some sort of sinusoid, and so is H. If I had to take a guess, I probably would... Is there another one there? This one looks like it could be something that's starting at the bottom and going up and coming back down. Yeah. Sorry. So I could also be a good problem. I'm going to take the I because that's the only one that looks like it starts at the bottom and it goes up like that. And that's what I drew over here. Look at it's what I drew over here. It's what I drew here. See? I'm going to go with this one as I. And let's look at number 2. Let's solve it to get an idea what it looks like. dy equals to 2x plus 4 dx. Integrate y equals 2x squared over 2. That's x squared plus 4x. Okay, that's just a parabola. What did I say about... I already said one of those pictures looked like a parabola. I'm going to go with that answer, B. Do I win any money? B. Come on, draw. All right, let's see. Constant. Let's see. That means dy equals 2 dx. Integrate. Y is 2x plus c. That is a line. That is a line. With when c is 0, I have that line. If c is 1, I have that line. C is a negative 3, I have that line. Same slope, too. Okay? Let's find that line. Find that line. Oh, I see it. Do you see it? Not a line, 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 not a line. This one's a line. It's only one. It looks just like what I just did. It looks almost identical to what I did. This is fun. J. And let's see. Do last one. You're gonna do the rest. What is there more? Let's do another trick here. Let's do dy equals 2 cosine of x dx. Integrate y is 2 sine of x dx. Not plus c, I mean. Sine curve. I think I saw that earlier. Number 6. Sine curve. I think I said it here. Yeah, I said this looks... Well, I was looking at that. There was only 2 of them that looked like a trig, wasn't there? Yeah. Oh, no. That was H. This looks like a perfect sine curve. It was that one. I'm going to go with that one. D. Okay, I skipped this picture here for 5. So dy will be equal to x cubed minus 3x dx. Y would be x to the 4th over 4. I keep saying plus, it's minus. Minus 3x squared over 2 plus c. I need a 4th degree. 4th degree looks, and it's positive 4th degree, looks like a Whataburger. But they could be really skinny, or they could be really fat, one or the other. Whataburger. Oh. Whoa. This looks like a Whataburger. I thought it was a trig function, but you know how it's getting like very vertical on the outside. It makes sense because as this goes out, it does this. It goes up. So I'm gonna go with H. I'm gonna go with H. Okay, I'm kind of excited. I'll do another one. Let me jump to number 8. That dy equals x dx, y equals x squared. We had a parabola before. This is not shifted left or right. So number 8, I had that one here. Where was that one? I'm going to go with F. See how easy it is? F. All right, I'll let you... You got 3 left. Come on, you can figure those out. And the last but not least, you have to be able to match a slope field to a solution. I'm guessing he's got solutions on the other. You can go either way. Let me copy this picture here. Put it to the other side. Hopefully it just takes the picture. It takes the whole thing again. I just want a piece of a picture. Why won't it let me take a piece of a picture? It doesn't. Anyway, copy that. Page. There's a whole bunch of solutions. How do I want to do it? And let me put it over here. Paste it over here. Make it smaller. And make it. All right. So what I might do is think about what family of curves I want again. So if I, that's my solution. So what's y prime? Y prime is, well, that's a particular solution. Okay, so is that what you want us to do? Match the given slope field and a solution to the different equation. So the original equation had to be a constant, because that's the only way when I integrate. If I say dy equals some constant dx and I integrate y equals some x plus c. But this c is 0. So if I find what happens when what is a line with y equals x plus 0, which of those looks like that? Do any of those look like? Well, what are we looking for? First of all, we're looking for a whole bunch of equations. Y is x plus 1. Well, again, we don't know what c could have been a 2, and then it would be 2x. C could have been a 3, and it's 3x. So the original differential equation, that could have been any number at all. My solution is some sort of y equals x plus line. So it's x plus 0, x plus 1. Think hard. Look. Here's 0. So let me draw. Could I see that line in there? That would be the line y equals x plus 0. This would be the line like y equals x minus 1. This could be the line y equals x plus 3. So that looks to me like C. Piece of cake. E to the x, it's the same answer, e to the x plus c. So e to the x looks like that curve. I need a bunch of those curves. And it could trick you because, let's see, I think jumping, oh yeah, I see these. I see this jumping out at me. I'm going to go with F. So far I've used up C and I used up F. And I don't always get them right, but I get lucky once in a while. Let's try this one. A whole bunch of parabolas. Not shifted left or right. Where are my parabolas? Not shifted left or right. Not a parabola. That's not a parabola. Here they are. Bunch of parabolas. Just there it is. Shifted down 1. Shifted up 3. I'm gonna go with A. You get the idea what you're supposed to be doing? A. Oh, I didn't do number 2. Let's do 2. X squared. So that would have been a. Wait, no, that's one I just did. A. I didn't do this one. Let me erase that. Oh, come on. What does 1 over x squared look like? Do you remember? Let's put it this way. If x is 0, then the function is undefined. So therefore, you can't even have a derivative at 0 either because the function is undefined. Let's just make a small table. Just do a -2. But when you square it, it turns into a 4. That's 1/4. Let's do a -1. When you square it, it still becomes positive. No matter what x you use, it becomes a 1. You put a 0, that was undefined. You put a 1, that also becomes 0.25. And you put in, I'm sorry, a 1. You put a +2, you still get 0.25. So the picture looks like this. -2, it's very, very small. -1, it goes up to 1. 0 is undefined. 1 is also a 1, and 2 is also 0.25. So I see this happening. Can y ever be negative? Y can never be negative because you're always squaring the x. So I see this happening. I see this happening. Let's look for that. Let's look for that. Let's look for that. I see it. Do you see it? Do you see it? Do you see it? Do you see it? See how it's getting very vertical as it approaches the y-axis. Very, very vertical. Very vertical. I'm going to go with D. Wasn't that bad. What did I skip it? I don't know. Where was I at? D, right? Is that what I said? Yeah. I did. So I got 1, 2, 3, 4, 5. Let's see. Cubics. Cubic. It's a positive cubic, so what does a cubic do? What's your table say? When you plug in a -1, it's still going to be a -1 because it starts at the bottom. Plug in a 0, 0, you plug in a 1, you get a 1. So this thing does this. That's what it does. Can you find a cubic? Cubic, cubic. I think I found it. You found a cubic? Starts down here, goes up here, boom. Starts down here, goes from boom. Yeah, I think so. I'm going to go with H. I'm going to go with H. Maybe you agree with me. Maybe you don't. What was I doing? H. All right. Let's do another trig. Y is sine of x. So the family of curves that looks like that. So, and repeats itself. Let's see. Trig is usually easy to find, and I think I see it right here, just when I was zooming in. It looks, I don't know, it looks like it could be, but the zoom is really weird. Could be that. Do I see anything else that looks like that? No. No. Oh, what's this one? What's this one doing? Could that be it? It's either B or E. What is your guess? You're not sure? There's a difference here. One definitely has a point at 0, 0. And this one at 0, it's really down here. So I'm going to go with B, but let me just go do the math over there. What happens if I had sine of 0? Sine of 0 is 0. So I'm going to choose B. It was making sense. Okay, the other one must be the cosine one because cosine of 0 is 1. So the other picture must be, where is that? Right here. I moved it. The cosine, that must have been this one because I got the, oh, it was either B or E, and that gives me the 1 value up here. If I zoom in on it and see, oh, come on. I could see that's going up. It's up there. Cosine curve starts at the top, does that. Yeah, see, cosine curve does that. I'm going to take that one, E. I don't always get them right. Sometimes I miss something obvious, and they'll call me Mr. Obvious at home. E. How many are left? There's only 3 left. Again, I'll let you finish those. Can't do everything for you. Only 3. Multiple choice question that can come up on the AP test. That's exactly what I was saying. They gave you one picture of a slope field, and you have to figure out which one it is. What's after? Let me see if we can do those. So I have a tie. Even 50-50, you can take a shot, but let's go ahead and look at another slope that looks kind of familiar. This looks like a 0, a 1, a 2, a 3, a 4. It looks like it's getting steeper as I go to the left. So let's pick a point. Well, let's also talk about something here. What's happening on the x-axis? It looks like there's always a 0 slope on the x-axis. So always 0 on the x-axis. So if I pick a point 1, 0 right here, which one gives me a 0 for 1, 0? So let me change color. Let me check. I have 2 possibilities, right? So let me check here. 1, 0. Does it give me, what slope does it give me? 1 times 0 is 0 plus 0. That one gives me 0. It's still a candidate. 1, 0 down here. 1, 0. 1 plus 1 is 2. So the slope is 2 is 8. It's really steep. So it can't be that one. I will keep my C. Got to test points. You find test points and say, what could this slope be? This slope could be about a -1. Plug that point in, -2, -2, -1, and see if you get approximately a +1 slope. Which one will work? Okay, open-ended, 9 points each, 3, 3, 3. So if you get one of these on the axis below, sketch it. Oh, we just did this. So let's just do a few points here. What I'm going to do is this. My ordered pairs, x's are -2 to 2. Y's are -3 to 3. So any combination of ordered pairs. And let's take these right here. Let's do those. Let's do the -1, 1, 0, 1, 1, 1, 0, 0, -1, -1, 1, -1. So let's do those points. -1, 0, -1, 1, -1, -1, 0, 1, 0, 0, 0, -1, 1, 1, 1, 0, 1, -1. He wants them all, but usually they don't make you do that many. But so your slope, keep in mind, my slope is always the x over the y. Your slope is always x over the y. So these are really fast to calculate. Slope, x over y, undefined. Slope, -1. Slope, 1. Slope, 0. Slope, undefined. Slope, 0. Slope, 1. Slope, undefined. Because if you can't divide by 0. So every time you have x, every time y is a 0, every time y is a 0, it's undefined. -1. Slope is -1. Let's do all the y's being 0. Undefined. That would be, if y is 0, then we have to keep these points sacred here. There's going to be no tick mark on the x-axis. So keep that in mind. Let's do the points that I have now. So I've already answered. I've already gotten rid of this one. I've gotten rid of that one. No, that's not true. I got rid of this one, and I've gotten rid of this one, and I've gotten rid of this one. So let's do -1, 1 is slope of a -1. -1, 1, slope of a -1. So 1 down, 1 to the left would look like that. Let's do -1, 1. That's what I just did. -1, -1, the slope is a 1. 1 up, so it looks like that. Okay, at 0, 1, it's a slope of 0. 0, 1, slope of 0. Let's see what happened here. Whoop, that's why he's erasing it. 0, 1. Why it got small on me. 0, 1 was 0. Oh, 0, 1 is 0. That one's 0. And then, where am I at? 0, -1 is also 0. 1, 1 was a 1. So that's looking parallel to this one. And 1, -1 is a -1. So look at these pictures. Beautiful. Those are beautiful. Something's weird happening. Let's continue this picture. I bet you any money that, and I shouldn't bet you any money because I might lose. Something is happening like this and like this. It's a weird picture. That's my guess just right now with only doing those few points. Moving on. Let's do another set of points. Let's do, let me take -2. Let's do -2, -1, -2, 1. I know it can't be -2, 0 because there's nothing on that. That's sacred. So, you want to be careful that you're not putting anything on that axis, okay? And so I'm just making that mark just to let you know that I'm not going to use anything there. All right, I did the -2, 1, -2, -1. Let me do -2, 2, -2, -2, 0, 2, 0, -2. Let me do 2, 1, 2, -1, 2, 1, 2, -1, 2, 1, 2, -1, 2, 2, 2, -2. So there's a lot of points there. Let's see, I might be expanding it pretty good. Let's see what I get. Again, it's just the first over the second. So this slope will be a 2. This slope will be a -2. This slope will be a -1. This slope will be a 1. This slope will be a 0. This slope will be a 0. This slope will be a 2. This slope will be a -2. And this slope will be a 1. All right, this slope will be, that was a 2, -2. That's a -1. And 2, -2. 2, 2 is a +1. 2, -2 is a -1. All right, one at a time. -2, -1. Slope is a 2, so it's got to be steeper than this one. So 1, 2, 1. Aim it up higher. There. That's that one. -2, 1. That's a -2. So that one, -2, 1. That's going to be, it's the opposite of this one. So it's going to go like that. opposite direction. Negative 2, 2 is a 1. Negative 2, 2 is a 1. Boom, boom. Looks like that. That one's done. Negative 2. And, oh, wait. I didn't do that one right. Negative 2, 2 is over here. I did 1. Negative 2, 2 is a 1. That one. Negative 2, negative 2 is a 1. One of these was a negative 1. Negative 2, 2 was supposed to be a negative 1. And that did, negative 2, 2. That one's wrong. That has to be a negative 1. Negative 2 was the negative 1. Negative 2, 2 is a negative 1. Negative 2 is a positive 1. Negative 2, 2 is a positive 1. Oh, yeah, you see what's happening? These are all, my opinion is still holding true. 0, 2 was 0. 0, 2 is 0. 0, 3 will be 0. 0, negative 1 was 0. 0, negative 2 was 0. All of those are 0. Okay, where am I at? 2, 1. 2, 1 is a 2. 2, 1 is a 2. So I have to go 2, 1 is a 2. 1, 2. It's steep. It's steep. 2, 2. 2, negative 1 is a negative 2. 2, negative 2 is a negative 2. 1, 2, 1 in that way. And 2, negative 2 is a negative 1. I did that. 2, 2, 2 is a 1. I did that one. 2, negative 2 is a negative 1. 2, negative 2 is a negative 1. What's 2, negative 1? 2, negative 1 was a negative 2. 1, 2, 1 is what's steeper than that one. Yeah. It looks like it's a reflection. Whatever's on top is the reflection. So finish that up, and you might actually get 3 to 4 points for drawing the picture. Usually they don't make you, the most I've seen really is like 9 points. Now sketch a solution to the curve that passes through 0, negative 1. Well, I can't sketch the curve because I haven't solved it. So I have to solve that sketch. Oh, no, he says use the picture and 0, negative 1. So 0, negative 1 is here. So in my point of view, I can't cross this unknown shaded region here. So it's probably going to be 0 here, going down, going down. There's my possible solution. And they'll be looking for that. If you had another point here, you'd probably would go out, keep going. But there's where I'm at. Now, that's probably only worth 2 points. Okay? It wasn't that hard. And then probably for 3 more points to get 9 altogether, find the particular solution at that 0, negative 1. So we're going to take our differential equation. This is part C. dy dx was x over y, as I recall. So dy will have the y multiplied on top. Basically, you're separating that. And x has that dx. It's not a hard one to solve. Integrate both sides. Y squared over 2 is equal to x squared over 2 plus some constant. And you can find C right now. It doesn't matter when you find C. If I just use my 0.01 right now, I'll know what C is. Before I multiply everything by a 2 and take the square root, let's just find C right now. So I plug in the 1. That's 1 squared over 2 equals 1 squared over 2 plus C. 1/2 equals, 1/2 equals 1/2. That's not very exciting of a differential equation. Do I have it written right? X over y? Is that what I wrote? Yeah, y dy. Yeah, it's just not very exciting. Sorry, guys. You were looking for some action. Minus a half both sides, you get c is 0. Boring. So that means the equation I will use is y squared over 2 equals x squared over 2. Solve it for y. Y squared equals x squared. Take the square root. Y is plus or minus x squared. Oh, except for at 0, 0, because the derivative was not defined when y was 0. These are just parabolas that are opening up, and I can even get another one here. This is not part of the answer. I'm just saying you have another one here that's close to the 0, but you have another one even closer to the 0. You just can't get to the 0. And then once you jump that ship again, there you go. You got more. You got more. But I wouldn't put the extra graphs on the AP problem because they're only looking for this red one right here. Oh, it's an upside down parabola and up a right side up parabola, except at the y-axis, x-axis, y is 0. Cool. That was fun. 2 AP problems. This will be your homework. Okay, so there's your homework. There's your homework. I will expect, let's see, you got 4 here, right? Yeah, that was A. You have homework, 4 slope fields, and 3 FRQs. You will have to submit them in its learning. I am done. Over and out. And a free response, different than that one. That one, I'm going to call this A. I think that was the first one. FRQA, FRQA, N. And the nice thing is, how do you get it wrong when I tell you which problem it is? Okay, notice how this is a more recent. You only have only on the dots they ask for. That's all you have to fill in. If there's no dot, you don't have to put it. There's 1, 2, 3, 6, 12 dots. Another free. Is it the same problem each time? Let me look. Is it FRQB? You out loud again. 1, 2, 3, 4, 8, 12 dots. Response. FRQC. We were 12 dots. They all seem to have 12 dots. Okay. Another free response. How many are there? FRQD. All right. So, and that's the end because this is area between two curves. You're a pro at that.